This animation has been created to highlight a Shell invention that will provide an additional layer of protection in the drilling and production of deep-water wells around the world. This tool will act as another line of defense in reducing worst-case discharge in the event that a total loss of control of a well occurs. Now, let's go aboard. The crew on deck is focused on completing a routine running of the 13 5/8" casing string into the well bore and cementing it in place. This kind of operation is being repeated over and over again on drill ships all over the world. After cementation, a 12 1/4" borehole will be drilled to a targeted depth of 14,500 feet and will penetrate the upper pay of the reservoir. Also in the string is Shell's newly developed technology, the Collapsible Insert Device, or CID. Invented and developed by Shell, the CID is a pipe-in-pipe device that has been designed to form a collapse of the internal insert of the device to significantly reduce or shut off an uncontrolled flow. The CID is another safety device that can be utilized in the reduction of a worst-case discharge. But more importantly, it's another means of protecting both the crew and environment. The CID itself is made up of a number of innovative components. The outer housing has been specially designed to withstand the stresses of the collapse while maintaining the structural and functional integrity of the casing string. The inner pipe or insert of the CID contains an energy source, a receiver, a trigger, and 3 pyrotechnic devices. When signaled, the pyrotechnic devices will generate an engineered collapse of the internal pipe. The trigger is encrypted and can only be activated by a specific code delivered by a non-invasive acoustic transmission from the vessel. This prevents unauthorized or accidental activation of the CID and provides the highest level of security around the usage of the device. Although it has a 1-inch offset beyond the outside diameter of the casing itself, the CID is handled just like any other casing component and integrated directly into the casing string during the run. To maintain constant and secure communication between the CID and the vessel, acoustic repeaters are installed around the casing every 1,000 feet. These devices consistently send acoustic signals through the casing to the CID, ensuring that the CID is properly receiving communication at all times. The vessel can activate a health check of the signal and receive feedback from the CID at any time. The acoustic repeater sends transmissions through the riser walls and casing walls, allowing real-time transmissions of the signal. The system requires no penetration of the blowout preventer or casing hanger. As we move through the riser system in BOP, we see existing 13 5/8" casings that have already been installed in the well, and we're ready for the next step in the well construction process, cementation. The cement is delivered in between spacer fluid and displaced around the casing, which seals and protects the well bore and the casing itself. The cement comes to rest just below the CID to ensure that the CID is not cemented into the well bore. This helps to maintain an optimum acoustic signal between the device and the vessel. The chute track is then drilled out, and our well has reached into the hydrocarbon reservoir, or hydrocarbon-bearing sand. The drill string is then tripped out of the hole. As the crew members on deck trip the pipe and stand back to joints, a standard operation on the drill ship deck, they're unaware of what's to come. While pulling out the drill string, the well has been swabbed in. Inflow from the reservoir now contains oil and gas and is traveling through the casing string toward the drill ship, causing an uncontrolled release of hydrocarbon, typically known as a kick. Facing a kick, the crew follows conventional methodologies to deal with the uncontrolled flow. First, the lower annuals are closed, but realizing this is not sealing off the flow, crew members attempt to close the pipe rams, but to no avail. If these conventional methodologies fail to stem the flow of hydrocarbon and the blowout prevention devices malfunction, we face the potential for a catastrophic disaster with a substantial loss of life and significant environmental damage. During the kick, it takes only seconds for the situation to become extremely dangerous and uncontrollable. With the CID from Shell, however, the drilling operator can significantly reduce or shut off all outflow by activating the device. The drilling operator first attempted to utilize the BOP device to shut off the flow, which failed. The CID is then used to prevent the release of oil and gas to the surface. The drilling operator then activates the CID from the driller's control panel, and with a simple push of a button, acoustic signals are transmitted almost instantly to the CID. The signals trigger the pyrotechnic devices, generating a collapse of the interior pipe and significantly reducing, if not stopping, the uncontrolled flow of hydrocarbon into the environment. A catastrophe has been averted. The collapse of the interior pipe is a three-sided collapse, which ensures that the flow is sealed shut or substantially reduced. Once the flow has subsided or been shut off, the crew can go into the wellbore and either mill out or drill out the collapsed insert, while maintaining full integrity of the existing casing. At all times, the integrity of the casing string is maintained. Shell has spent a tremendous amount of time and resources developing the collapsible insert device technology. Introducing the device to the industry will substantially reduce the risk of system failures in drilling environments. Companies across the globe will have a safer and more effective way to explore and develop hydrocarbon, while addressing the world's increasing energy demands.